XSS or cross-site scripting is one of the oldest tricks in the books, but trust me, it's still very relevant in today's web security landscape. And today, you will learn how to master it. More specifically, you will fully understand reflected XSS. To understand XSS, let's start with the basics. Let's understand how a web page is structured. A web page is constructed using various components, and each of these components is called an element. These elements are identified and organized using tags. Think of tags as labels that categorize and define each part of a web page. So in essence, these tags in HTML function as the fundamental components, dictating the layout and appearance of a web page. Understanding and using these tags allows developers to create and present content in a systematic manner on the web. For example, the table tag represents a table, allowing you to organize data in rows and columns. If you want to create a paragraph, you'd use the p tag, and for headings, you have h1 to h6, each indicating a different level of importance and size. In this example HTML file, we have the essential structure of a basic HTML document. Starting with the HTML tag, it indicates the beginning of our HTML document. On the opposite side, we have the closing HTML tag, indicating the end of the document. The same goes for almost all other tags. Following that, we have the body section contained between the body opening and closing tags. Inside the body section, we find the content that will be displayed on the web page. The first H1 heading displays Subscribe to. Following that, a H3 heading displays InfoSec Mastery. Lastly, we have a button element labeled Subscribe. This structure serves as the foundation for creating various content elements in HTML. Finally, let's discover the script tag in HTML. The script tag in HTML is used to embed or reference JavaScript code within an HTML document. JavaScript is a programming language that allows you to add dynamic behavior and interactivity to your web pages. The script tag can be placed in the head or body section of an HTML document. Here is a basic example of how the script tag is used. In this example, the script tag contains a simple JavaScript function named greet. This function displays an alert saying, "Hello, subscribe to InfoSec Mastery," when called. The button element in the body section triggers this JavaScript function when clicked, demonstrating the interaction between HTML and JavaScript. Now, after all these shenanigans, where is the XSS attack, you may ask? Well, take a look at this page. This is a simple web page that asks for your name. When you visit the main page of the website, you see a question asking, "What is your name?" And the page is expecting you to put your name in the URL for the page to display it back to you. For example, if you visit 127.0.0.1 input equals InfoSec Mastery, the web page will display "Welcome back, InfoSec Mastery" on the page. The interesting thing about how web pages work is that when you add something to the page that looks like an element, it will interpret it as an element, which means instead of putting my name, I can put a H1 tag that says hello. And when I click enter, I can clearly see that the page didn't just simply print out the text I gave it, but it interpreted it as a H1 tag, that since it looks bigger to the usual text. Another interesting thing is that instead of adding a H1 element, we can add a script element. Because remember, script elements allow us to execute JavaScript, and executing JavaScript is what will allow us to perform the infamous cross-site scripting attack. To do that, it's pretty simple. We just create a new script tag, we put an alert1 function as the JavaScript code that will be executed, and then we press enter. As you can see, an alert pops up on our screen with the number 1. This in itself is a confirmation of the existence of the XSS vulnerability. Well, you might be saying, "It's not interesting, is it? What can we even do with this?" I am about to show you, just be patient with me for a second. On the website, we have some things called cookies. Cookies are small pieces of data stored by websites on a user's computer. These data files serve several purposes, such as remembering user preferences, storing session information, and tracking user activity. Cookies are commonly used for tasks like keeping users logged in, remembering items in a shopping cart, and customizing website settings based on individual preferences. Cookies are crucial for maintaining stateful interactions between a user's browser and a website, contributing to a smoother and more personalized browsing experience. So, if we can steal these cookies from other users using JavaScript, that attack would be very interesting, wouldn't it? Because when we can steal cookies, we can simply take over the account of that user, just by telling the website, "Hey, I am the admin user, and I can prove it." And your proof is the cookie that you stole from the admin user, of course. So, the way we can do that is, we go back to our XSS attack payload, and we just simply swap the number 1 with document.cookie. This will print out the cookies stored for the current document, meaning the current website, hence the name document.cookie. When we do that, you can see that we get our usual pop-up, but this time it says user cookie equal and the value of the actual cookie. So this confirms that we will be able to get the cookie through JavaScript. Now, how can we actually steal this cookie from a user? The simplest way is to send it to another website waiting on the other side. Let me demonstrate that. Here, we have a website called RequestBin. RequestBin is used to receive HTTP requests. The usage is simple. You create a public bin, you get the link, and then you just ping it. When you ping it, you can see that a new request is generated in RequestBin. Now we add a new parameter in the request. We can add a variable a equal to XYZ and send it. On the RequestBin website, we see our new request and our parameters. Now, what if we go back to our vulnerable website and execute some JavaScript code to send the cookie to our request bin? Well, that's exactly what we are going to do. In our JavaScript payload, we are going to use a redirection property instead of the alert function, which is window.location.href. Basically, when the vulnerable web page loads, our JavaScript code will execute, and the redirection property will take us to the request bin. We try it, we take our new payload, execute it, and see that we get redirected to our request bin. Now, instead of just making a request to the request bin, we are going to add the document.cookie that was explained earlier. So we just concatenate document.cookie to our redirection URL. In URL encoding, the plus character is encoded as a %2b symbol. This encoding is used to represent special characters in a URL, ensuring that they are transmitted correctly and don't interfere with the URL structure. So, if you have a plus character that needs to be included in a URL, you would replace it with a %2b symbol. If you don't know what I'm talking about, I made a video on encoding if you want to check it out. Anyways, we now take our newly created XSS cookie stealing payload, run it, and see the results. On our application, we can see that we have been redirected. And when we check the request bin, we see that the session cookies have been sent as well. In this case, we have sent our own session cookies to request bin, which doesn't really make sense because they are our own cookies. So, an attacker can give this specific link to any victim. As soon as they open the link, their cookies will be stolen. I will demonstrate this right now. I will take the link, open a new private window so the old cookies will not be here, and the server gives us new cookies. In theory, this can be considered as a completely different user. So as soon as we enter our malicious link, we get redirected. And when we check our request bin, we find that we have new cookies that we received, and these are the cookies of the second user. This attack is called reflected XSS, and the reason why it's called reflected XSS is because the malicious script or payload is reflected back to the user by the web application. In reflected XSS attacks, the injected script is not stored on the server, but rather immediately included in the response sent to the user's browser, just like we witnessed. You seem to be a fan of pen testing since you are still watching. So here is another web application pen testing video that will teach you something about becoming a better hacker.